Hello, welcome back to the channel. Today, I will start a new series of tutorials in which I will introduce some experimentations I did on using generative AI models like ChatGPT or Claude to improve the user experience of supply chain analytics product. Basically, I will take some algorithms that I have deployed in the past for production planning or route optimization, and I will add an AI layer on top to improve the interactions with users. For instance, instead of clicking on buttons on a dashboard or a web application, you can send an email to the agent with the type of information that you have and the objective function that you want to optimize. And a few seconds later, you will receive the answer. Today, we are going to do that with the production planning optimization algorithm. Let me show you the details. Imagine that you are working in the production planning of a manufacturing company. You are based in a factory. This factory receives purchase orders from different customers. In these purchase orders, for instance, you have the demand per month. And it could be here, like here, for instance, in this Excel file, where for each month of the year, or each of the 12 months that will follow this month, you have the expected quantity. So for instance, in the month 4, you expect 50 units to be produced. And you receive that in an email with some additional information. So you know that the period is by months. You know that the units is not the pieces, like I said, but boxes. The currency is euro. And you know that you have some financial information, like the setup cost. So you know that every time you set up a production batch, you have to pay 800 euros. And the holding cost. So each box to store costs 2 euros per day. And what you want is to ask the tool, so here the supply chain analytics products that we are talking about, which is production planning, to provide the best scenario, the best planning for the next 12 months to minimize the overall cost of setup and holding. And for that, we have an algorithm. So first, you send that by email, all right? Then we are going to my favorite tool, which is Anyturn. And here we have a workflow that will first be triggered by the fact that you are receiving an email. So let me execute that. On the top, what you are going to do, you are going to extract the attachment, which is this CSV file where you have the content of the number of boxes that you have to produce per month. And then you are going to send that to an API, a FastAPI endpoint that will save locally in your VPS the production plan that was sent by email. And then you will have an AI agent that will parse the email, take the right information, all the parameters, and then you have a second agent that will call this API to ask the production planning tool to provide the best plan, and then send that by email. And if you wait, so I think it's already done now. If you go to your mailbox, if you refresh, you have received an email with the detailed summary of the planning, with the optimal planning. So you are meeting the demand in 12 months. The maximum demand is 300 boxes. And I think if we go back, it's the case here. It's 11 months. It's the month 11, sorry. Maybe let me go back to the email. And then you have the quantities that you have to produce every month. So the first month you produce 350 units, and then the second month you don't produce anything, blah, blah, blah. And most importantly, you have the total cost with the setup and the holding cost, and some recommendation generated by the AI agent. Today, I will explore with you how I built that. But first, maybe let's go more in details on how the algorithm is working. Now that you know what we want to achieve, we can go back to the theory to have more details on what the algorithm is doing. So let's have a scenario where a customer is sending what we call a purchase order. So he's saying to his supplier, I want to receive that many units at that period. And this is basically what fed our CSV file, where you know that for the next 12 months, the number of boxes that you need to deliver to the customer. This purchase order is received by the production planning team, and then they add on top some additional information to generate a production plan for the factory. So the factory can know every month how much units they have to produce. And based on this production quantity, there will be an inventory. What's the problem? The main issue is, first, we want, like always, to minimize cost. But the cost depends on two parameters that can be antagonistic. The first one is the setup cost. So factories are organized in batches. Every time you have a batch, you have to set up the production line, and you are producing a certain quantity, and then the production line is stopped. When you set up this production line, you have what we call setup costs, which are basically fixed costs to set up the line. So the best way to minimize these costs is to produce the overall quantity for the next, for instance, 12 months in our case, the first batch. But the problem is that you are going to build inventory, and this inventory is not free because you have what we call the holding cost. So first, in terms of finance, in terms of cash flow, this inventory that is sleeping costs money, but also just operationally, you have to store this product inside a warehouse. And for that, we can measure it by the number of units per period. So the best way to reduce this holding cost is to produce each month only the quantity that has to be delivered to the customer. But then you go back to another issue, is that your setup cost will explode. So you need to find a balance between both. And this is why we are using the Wagner-Wissing algorithm that is taking the demand, the setup cost, the unit, the holding cost, to find the perfect planning. And the results looks like this. So these screenshots are based on the web application that I have designed and deployed. I can share the link in the description, and I will give you a quick demo on how it's working. So you can visualize the demand, which is basically what you can find in the CSV file. And then here you have the optimal production plan. So for instance, here in that case, you only produce 4 months, the 1st, the 6th, the 9th, and the 11th. And here you have the different production quantity. And here you have the evolutions of the cost. So based on these parameters, this is the optimal plan that you want to share to the production team. What we want to do here, and in more generally in this series of videos, is to show how we can use AI to exploit this model with different user interface. Instead of relying on the web application, you can, for instance, discuss with an AI agent or send, like I did, the request by email. And for that, I am wrapping around the core module, so that is hosted on a VPS with the FastAPI endpoint, an AI agent that will receive the user's request, process them, call the backend, the endpoint of the core module, exploit the analysis, and then provide the results with some summaries, figures, and sometimes charts. And this is what we did to have, for instance, this solution. Now I will show you how I did it, how I prototyped it using n8n. So before jumping on the n8n workflow, I wanted to show you what is the current user interface and how it looks like. So here, this is the free, publicly available web application that we have developed. It's a kind of a demo version. It's a Streamlit app that is connected to our FastAPI backend. If you go on supply chain optimization and if you choose production planning, you will find the algorithm for production planning. And if you go on analysis tab, you will have the window where you can play with the algorithm. So in terms of parameters, you have the units. It's more for the visual here, what to show here. You have the period definition, so which months we are talking about, the currency, the setup cost, and the holding cost. And for instance here, if I go on production planning, the current production planning has only 4 production batches, which means here that we favor more setup costs than holding costs. So we try to minimize the number of batches because it's less expensive than having high inventory. But what if, for instance, I multiply by 10 the number of setup, the cost per setup? what you will see is that now we have 2 setups, so which is even worse. But if I divide it by 10, normally you will see that we produce nearly every month. Yeah, which is the case. So here, what you could see is that you have your production plan with the cost, all the parameters. You can explore that yourself by playing with the user interface. And what we want to do now is either to change this user interface to a chat that we talk to or to an email that we send. So I will show you how to do that. As I told you, so I have hosted this module on FastAPI backend on my actually on the same VPS as I host my N10 instance. So in here it's more an experiment. So I have multiple routes, one for production planning, one for workflow planning, which will be the second video. And each route are basically sending to endpoints that are linked to one algorithm. So for the production route, for the production planning, so we have 2 endpoints. The first one is to upload the CSV file that I showed you. So in that is taken from the attachment of the email. And the second one is to launch the algorithm. We are managing the sessions. And here what is interesting, if you want to have a look, is on the parameters that are used. So here, these are the parameters to launch the algorithm. These are the parameters for the visuals that are not used here. And on the parameters to launch the production planning, you have the period, months, day, week, the units. So if it's boxes, pieces, pallets, the currency, the setup cost, and the holding cost. And you will see that these are the same parameters that you can find in the email. Now let's see how N10 is connecting to these endpoints. Now you have enough context to understand how it's working on N10. So first, it starts with a Gmail trigger. So this is a normal trigger that is widely used. It will be triggered every time that the target mailbox, so here's mailbox that I'm using for all these experiments, will receive an email. So in that case, the email that has been received is the one that has sent to myself with the attachment. So what you have to be careful here is don't forget to select download attachment because you need the attachment in the CSV file. And you can check every minute. And then what you do. So the first step is you extract the attachment. So everything that is on top for N10 is done first. You know, it's going from left to right, from top to bottom. With this node, it's extracting data from a binary file, and this binary file is generated by the Gmail trigger. And then I think here, what you can put as an option is the delimiter. So here I put this delimiter based on the way that my file is generated. And what you could see is that you have the different items here in this beautiful table. And then what I do is I push that via a post request to the backend, to my backend, and to the endpoint upload data that will receive this information, which is all the number of units that you have to produce per month, and save that in the folder using the session ID. So here I'm using session ID on my backend. If you don't use session ID on your backend, you don't need that. But in the deployment that we are doing, basically the web application can be used by multiple users. So it's better to have several session IDs so that way each user is using its own data. One important thing here is on the data, I added I specified that I want to transform the data into JSON strings, so that way it can be received by the backend. So here what happened is that to give you the full picture, I tried without having this special formatting for the body, and then I had some errors on both sides. And I asked ChatGPT, I asked Claude how to solve this, and he proposed me this expression. I'm not a huge expert in JavaScript, but with the support of LLM, it's easier. Then, now we are talking about the content of the email. So the email, you have the attachment where you have the data, and inside the body you have all the parameters that you want to set up here. remember that we have multiple parameters that are required by the endpoint. So this first agent is just parsing the content of the email to extract all the different parameters. So in entry, you have the email. So you take the email, you take the header and you take the body. So where is the header? Yeah, so the body is here, text version, and the header is the subject over here. And then in the system prompt, we provide some context. So we explain the type of information we have to extract. So here I've been listing them. And we want to return a valid JSON object because it's going to be used later by this agent. And for that, we have a structured output parser. So this node provides you the possibility to give to the model an example of the type of output that you want. And here it's exactly mirroring the 5 parameters that the endpoint needs. Then we have the second AI node. This one will take the input, so the different parameters, and send a GET request to the endpoint launch that we launch the algorithm and get the results. So in the system prompt, what we do, we provide some context. We explain that we are going to receive 2 blocks of data as output. We explain what type of parameters that we need to run the production planning model. And we provide also some information on the output requirements. So here we want to send like a prettify answer by email. So I asked the agent to generate HTML format output, so that way we can directly put that in the Gmail node. And here we can, I think I provide some, instruction on the different headers that we want. And the output looks like this. So you see it's like HTML format. How does it generate this output? First, I don't know if we can have the details here. Yeah. So what happens is that the agent receives, so here this is the system prompt. It sends a query to the endpoint using this node. So this node is connected to my endpoint. And here I put in the headers, I put a random session ID. This is only used for the test here. Here, very interesting point. So these are, in the body, these are all the 5 parameters. So I manually put the name of the parameters. But for the value, I clicked on an option, and I don't know if I can add it. I clicked here. So you can ask the model to define the value. And the model will receive, if you remember well, if you receive the JSON with the 5 parameters, so it will automatically guess what kind of output she needs to provide. And these are the different outputs that will be provided. And this is the response that it receives. And based on this response, is generating this email in HTML format. And then you connect that to a Gmail trigger, that trigger a Gmail node. Here in the message ID, you take the same ID as the trigger node. So that way you answer in the same, if I go here, there should be an ID. Yeah, thread ID here. So that way you answer in the same discussion. You don't need to put a subject because it's a reply. And the output is the output generated by the agent. And if I go back to the email, here is the answer. You have the 4 different headers that have been asked in the system prompt with all the different information. Just for your information, the same exercise can be done with a chat. So if I go So here is the chat version. So we connect here a chat node. The system prompt is roughly the same, but here you don't need to ask for an HTML output. What else? You provide some instructions on what to, you need to onboard the users because it's a chat. So that's what I added here, but the rest is the same. And it's directly connected to the chat interface. You have here, since it's chat, you need to add a memory. And here you have the same tool node that is connected to the backend of my API. And here, like before, all the different parameters are defined automatically by the model. And we can try it together. Oh, hello. Ah, yeah, there is an error in the chat model. Should be done now. Yeah, let me clear it. Hello. Can we do planning with planning? I will ask that. Let's see what he answers. So what you could see here is that it's only calling the OpenAI node and the memory. So it doesn't call yet the API. What he proposed, so he explains me the different parameters, but also as I asked in the system prompt, he proposed me a scenario where you have preset values. Okay, let's do it with preset values. Here. So what you could see is that the OpenAI model node is calling the API node. The API node is generating a results, and these results are used to answer. So here, these are the input parameters and the default one. And these are the results, like in the email, and it's exactly the same format and with a cost summary. So 6,600 euros. What happened if the holding cost is 1.5 euros? Let's see. It's supposed to be lower. And if the holding costs are lower, we are supposed to have less production setups, because here we have 1, 2, 3, 4. No, wait, these are the ones. 1, 2, 3, 4, 5. So now with the lower holding cost, we are supposed to have less. Let's see what happens here. 1, 3, 4. So one less, and we have a reduction of the cost. So here is another way to interact with the agent. I hope things were clear enough. That gave you some insights on how to do production planning with an AI agent connected to a simple algorithm. And for the algorithm, I will link the GitHub repository in the description of the YouTube video, and create something more interactive for the users. If you have any questions, feel free to use the comment section. And see you for the next video that will be about workforce planning.